Hi, my name is Dai Matsuzaka, and today we're going to be working with Chapter 5.5, Circle Equations. Now, the circle equation general form is the following. You just need to know this, memorize this, whatever it takes, do some practice problems. But x minus a squared plus y minus b squared is equal to r squared. This is the circle equation general form. Grill this into your head. Now, given that general form of the circle equation, we can actually derive two things. One is the center, and one is the radius. So A and B is the center. What does that actually mean? Well, if you input A and B into this, what do you get? We get 0 on both sides. So we actually get the minimal value of this function. What is that actually telling us? Well, it's actually telling us that that's actually the origin, the center of our circle. And what is r squared telling us? Well, r squared, it's squared right now, but r on its own gives us the radius. This is r. This point here, which is at the center of the circle, is AB. Now, you don't really need to know, again, the derivation of this. You just know that if you can bring an equation into this format, then we can actually talk about what the circle looks like in the xy plane. Now, let the equation be defined as something like x squared plus 6x plus y squared plus 4y. Now, like, this doesn't really tell us anything and doesn't look like we can, solve it. But this actually is a very interesting identity, right? If you remember complete the square, all we do here in this case is we just do exactly that. And if you complete the square, we have x plus 3 squared minus 9 to complete the square for the x squared plus 6x. And then we also have y plus 2 squared minus 4 equals 0. So this is a plus. Then if you just isolate for the squared values, right, then we get x plus 3 squared plus y plus 2 squared equal to, this is 13. Right. So now we have the general form of the circle equation, right? I mean, technically you would have to do square root of 13 squared. Now, what does that tell us? Well, this equation is actually describing a circle centered at, I think it's minus 3, minus 2, around here, with radius square root 13. Sorry for my lopsided circle. But as you can see, this equation gives us the information for the center, right? What's the center for the x value? Minus 3. How about y? Minus 2, right? Because that then equates to 0. And what's our radius? Well, we have 13 prior, right? But 13 needs to be in squared form. So if you take the square root of 13, then that square is 13, right? So then square root of 13 is exactly r. Let me just make that very clear. So we had the general form of the circle equation equal to 13. This is equal to r squared. So what is r? R is equal to square root of 13. Notice that it's not going to be negative because radius is not well defined when it's negative. Now, yeah, so this is just generalizing, right? If we are given an equation of this form where we just have a bunch of things on one side, then it doesn't look clean, but if you just complete the square, then as per the previous example, we can actually arrive at the general equation. I can actually do this for you in the general case. This is actually going to look a little bit messy, but we have x plus a over 2, a over 2 squared plus y plus b over 2 squared equal to, and get this is great. I'm going to erase this part, and that is equal to square root of a over 2 squared plus b over 2 squared minus c all to the power of 2. This is just the generalized version, and you don't need to know this. Just be able to actually complete the square when given stuff like this, right? So this is a good practice. If you see this kind of question, complete the square. Try it out. And then when you have that completed square and you isolate for that one constant, make sure that you square it, right? In this case, we had that constant 13. Make sure you square it and take the square root and the square. That's pretty much it for circle equations. I'll see you next class.